In this session, I am going to explain what is balanced binary tree and binary tree implementation. In binary tree implementation, first I will explain how binary tree is created. Then, what is balanced binary tree? Here, the balanced binary tree is which both the left and right tree differ by at most 1. That means it can have one less child. For example, here AVL and red black trees are balanced binary trees. Let us understand the balanced binary tree through example. Here I am taking an example. Here you can see a a root node 4 is having two child, that is 2 and 5, and this 2 is in a parent node for 1 and 3 and 5 is in a parent node for 6. Now the above tree is balanced binary tree because the difference between left subtree and right subtree is 0. See here you can observe it is balanced because the difference between the left subtree and right subtree is 0. Now here you can observe a root node 11. It is consisting of two childs, that is 12 and 13, and this 12 is having this is a now parent node for 14 and 15, that is it is having two childs, and this 14 parent node is having another two child, that is 16 and 17. The above tree is not balanced binary tree because the difference between the left subtree and right subtree is greater than 1. See here you can observe it is 1 and this is 2. Therefore, it is not balanced. The balance means it should be have been balanced from right and left subtrees. Here in this diagram it is not balanced. Therefore, it is not a balanced binary tree. Then binary tree implementation. Here we can how it is implemented. That means how it is been created. I will explain with program how it has been created. Then what are the steps to be involved to creating a binary tree or implementing a binary tree. A binary tree is implemented with the help of pointers because pointers we will use, it will stores the address of the next variables. Therefore, it is very easy to access. For that reason, we are using pointers. The first node in the tree is represented by the root pointer, and each node in the tree consists of three parts, that is data, left pointer, right pointer. I have said that it is a node, it is partitioned into three parts, left, then center one is data, and right one is a right pointer. Here pointer which stores the address of the next node. To create a binary tree, we first need to create a node. As I said, the first we should create a node. Now let us see how the node is created. In previous slides and previous sessions, I have explained how nodes are created, but still going to explain how it is declared. I think now you came to understanding or you can remember this function. Here node is declared struct node int data, then struct node left, that is this is a pointer variable, left or link we can say, and struct node right or link. Here this one is called as a self referential structure because see the data types which we have used, that is taken here. This is and this and this. This is called as a self referential structure. In the above structure, data is the value. That means the values which should be stored in the node that is inserted, and left pointer contains the address of the left node and right pointer contains the address of the right node. For this reason, we are using the pointers. See here, you can see. I have told that in pointers we will use star to identify the pointer variables. If it is not a star, then we will take that one as a normal variable. If it is having star, then we will take that one as a pointer variable. Now, see here binary tree, how it is implemented using C program. First, I will declare the what node. Here struct node int data struct node, then two links I need, one is left and another one is right. See here, if it is a node, here it is should be connected left side and right side. I have said that we should always begin from left to right. Then I am calling a main function and I am declaring first node as a root node. Therefore, I am naming the node as root, and root equals to create function. Here I am calling a function that is create. Now I am using a structure struct node create. This is a functions. In that I am taking struct node temp. Temp is a temporary variable I have used, and int is an int data. This is an data where I want to actually insert an item into our node. Now I will allocate a memory to a temp variable. For this I am using a dynamic memory allocation that is called as malloc. Here you can see temp equals to struct node star malloc size of struct node. Here what happens, the node will allocate a memory to the temp and it is can be considered as a temporary node. Now I am taking one press to exit, that means to press 1 for new node. That means if I want to create a new node, I will press 1. Otherwise, if I want to exit, I will press 0. Next, I am taking the choice. That means here you are entering the choice 0 or 1. When you enter, that variable should be scanned. For that reason, I am taking a scanf %d and I am %choice. That is %d. It is a control string of an integer data type, and ampersand choice means which is having the here ampersand represent the address of the choice variable. Here you can see have entering a choice. Next, what I am doing, if choice equals to 0, return 0. I have told that if it is a 0, I should come out of the loop. That means I should get exit of the loop. Therefore, if the condition is true, then it will come out of the loop. Otherwise, what happens, else part. This is a false part. What happens, print enter the data scanf %d data. You assume that I have entered a data as 10, that is scanned. Now I am assigning this data to a temporary node. For this, temp of data equals to data. That is now temp of data equals to 10. It is temp having totally 3 fields. One is right, left and data. In data it is stored what, 10. Now print enter the left child. Now I have said that before we should always begin from the left of the root node. For that reason, enter the left child of the %d data. I am beginning from the left and temp of left equals to create. Now I am creating a left node. Similarly, next I will move to the right side, enter the right child of %d, that is integer data. I am taking that one. Next I am assigning temp of right equals to create. Now I am creating a which one, right side. Now totally I am creating 3 nodes. Then return temp. Then I am closing the main function. The above code is calling the create function recursively and creating a new node on each recursive call. In recursion, I have said that what is recursive function. A function which call itself is called as a recursive function. Here create is a function which I called it is an recursively. Therefore, when all nodes are created, then it forms a what beautiful binary tree structure. Thank you.